Hello, dear learners. This is Arif Khan Pathan, and today we are going to deal with the topic heterocyclic compounds. What are heterocyclic compounds? First of all, before directly going with the heterocyclic compound, we'll see the basics. That is the periodic table. We know very well periodic table. We already studied. It has a different components that it has columns and rows. These are the say columns of periodic table, and these are the rows of periodic table. Horizontal, these are the rows of periodic table, whereas vertical are the columns in the periodic tables. So two things basically present in periodic table we know, and the elements are organized in periodic table with a systematic manner according to their atomic number. Like for example, hydrogen is atomic number 1, has atomic number 1. It means that it has the number of electrons in the hydrogen, that is 1. That depends on the number of electrons present in the elements they are arranged, and that decides the atomic number of that particular elements. So any elements, if you want to find it in the periodic table, so it take its place according to the atomic number, means the number of electron present in that atom. So the different colors indicate the scheme in the periodic table, that these, like for example, these are the alkaline earth metals: lithium, sodium, potassium. All these are the alkaline earth metal. Then next we see these are the lanthanides. Then these are actinides. Light purple color indicate the actinides. Then transition metals are there. Then if you are going for poor metals, next, then green color indicating which are other non-metals. All these are the non-metals, like carbon again coming in the non-metals, nitrogen, oxygen, fluorine. All these are non-metals, whereas last column in the periodic table indicate which will fulfill of its shell, outermost shell, which will be filled up, and they are inert. They are not taking part in any of the reaction. That's why these are called as noble gases. Mostly these are gases state they are existing, as well as these are called as noble gases. Noble, why? Because they are stable, they are not taking part in the any of the reactions. So this is the short review of periodic table. If you want to go to study the periodic table, then some basic things we had studied about the periodic table. Next, the structure of atom. So this is the structure of atom. Indicate that this is the nucleus. This is the nucleus, concentric nucleus, whereas these different shells are there around the nucleus, in which the electrons are arranged. Electrons are arranged in outermost shell. Means electrons are not part of the nucleus, whereas the neutrons as well as the protons, neutrons and protons, like red color particles are proton, whereas yellow color particles are neutrons. So both of these are present at the center of atom, to the core of center of atom, and these are called as nucleus or nucleons. The particles which are present along the nucleus are called as nucleons. Means the proton and neutron are nucleons, whereas electron, which are the blue color particles, they are arranged in the different shells, and they are revolving around the nucleus of atom. So these are the components of atom, which has three different particles. Now as far as the charge are concerned, so the protons are positively charged, the neutrons are neutral in charge, there is no charge on the neutron, whereas electrons are negatively charged particles. So as we see the number of, as the number, if we compare the number of these particles in the atom, so normally it will be same. Number of protons equals to number of electrons, means the number of positive charge equals to the number of negative charge, indicate that the atom is electronically neutral, which has the same equal number of positive and equal number of negative charge. Next, now we are moving towards our topic, that is organic chemistry, how one can define the organic chemistry. Simple. Organic chemistry is the branch of science, is the branch of chemistry which deal with the study of organic compounds. Organic chemistry is deal with the organic compounds. Now, if you if you want to see about the organic compounds, the organic compounds are of two basic types, that is open chain compound and a closed chain compound. Open chain compound will be unbranched as well as a branch, whereas closed chain compounds, these are the examples, whereas closed chain compound may be homocyclic as well as heterocyclic. So open chain compound, if you're talking about open chain compound, they are open end to end, whereas closed chain compounds are also called as cyclic compounds, which are closed end to end. They are joined end to end, and hence they are forming cyclic structure, and as they are cyclic, that's why we are calling closed chain compound. So that's the basic difference between the open chain and closed chain compounds. Whereas in open chain compound will be the branch as well as unbranched. That is also called as straight chain compound. Unbranched compound are called as straight chain compound, which doesn't have any branch. They are only straight away. That's why unbranched. Whereas on the straight chain compound, if there is a presence of branch, as called as, or any tree or any shaft is there, that is called as branch compound. We have example n-butane, 2-methyl propane. These are the examples of branch compound. Now the topic of our interest, that is closed chain compound, and amongst these again not homocyclic, we are dealing right now with a heterocyclic compound. That is the topic of our interest. So these heterocyclic compound taking place amongst the organic compound, that the heterocyclic compound will be the closed chain compound, as well as they are organic compound, as well as they are closed chain compound. So if you want to deal with the heterocyclic compounds, they are organic compounds, organic compound in that they are closed chain compound, as well as they are again having the heteroatoms, that's why heterocyclic compounds. So now we are going to define the heterocyclic compound, that is our topic, heterocyclic. Now you got the idea where exactly the heterocyclic are placed in the general classification of organic compounds. So the definition of heterocyclic compound: heterocyclic compounds are those which possesses cyclic or ring structure with at least two different kinds of atom, or with at least one heteroatom. Now we'll get clear with the example, that in these we will see the two examples, one of the homocyclic, second one of the heterocyclic. Now this is an example, this is the structure of benzene, in which all are carbons, all 6 members are carbon, all members are carbon, that's why all are same, and that is why we are calling this is an example of homocyclic compound. Benzene is an example of heterocyclic compound. Now see the next structure, in which one of the carbon got replaced with the nitrogen. You can see that nitrogen is coming place in of carbon, it means that it got replaced. Now all the atoms are not same, means two different kinds of atoms are present in given structure. Like one type of atom is carbon, second one type of carbon, second one atom is a nitrogen. It means that we can say that first definition will get prove that cyclic compound, definitely it's a cyclic compound, closed chain compound is there, and with two different kinds of atom, it means it is an example of heterocyclic compound. Whereas heteroatom, it should have at least one heteroatom, so nitrogen, it is an heteroatom. So in this given structure of pyridine, nitrogen is one heteroatom in the cyclic chain, that's why we are calling this is an heterocyclic compound. So homocyclic and the heterocyclic compound. So that may be at least one heteroatom, means maybe a chances that there may be a more number of heteroatoms will be there in the heterocyclic compound. Now in the given example, only one carbon got replaced with the one nitrogen. Sometime second carbon will again replace with the second nitrogen, maybe with the oxygen, sulfur, different heteroatoms may be added, maybe a one ring structure, two ring fused together, that depends. So this is all about the heterocyclic compounds. Now just I told that heteroatom may be nitrogen, oxygen or sulfur. Any of them will be present, will take part of the carbon, will take place of the carbon and behave as a heteroatom, and the making ring from homocyclic to heterocyclic. Now, benzene, most of the time we are crossing over the example of homocyclic, that is benzene. So in this given, we can see the structure of benzene. So this is the say equilibrium structure or equilibrium structure of benzene, in which you see that the carbon skeleton structure of benzene. This is again a carbon skeleton structure of benzene. Only difference between these two structure is the position of double bonds. You can see that the double bonds are in these and in these, they are alternate. Like whatever the position of double bond in this first structure is being changed in this second structure, but they are alternate. Similarity is that both are alternate. In both the structure, the double bonds are alternate. Same, the benzene ring structure can be drawn by following way. Like this is the line form structure, this is the carbon skeleton form structure. Line form, in which we are simply drawing a line. Hexagon we are drawing and showing the double bond. This is the line form structure. Whereas where exactly we are drawing the exactly we are drawing the carbon atoms and the hydrogen atoms, this is called as carbon skeleton. Line form structure and carbon skeleton structure. So these are again the parallel structure, or we can say that homologous structure of benzene. Either you can draw in this way, in that way, in this way, or by this way we can draw, or simply you can write the formula for benzene, that is C6H6. This is the molecular formula for benzene, and these are the structural formula for benzene. Now the speciality with these double bonds, alternate double bonds, indicate that these three alternate double bonds are pi bonds, and these pi bonds are made up of pi electrons. So now if you see the three-dimensional structure of benzene, so these are all the carbons, and red indicate the hydrogens, and above and below the plane of benzene ring there is a cloud of electron. You can see in the given structure that the electrons forming a cloud above as well as below the plane of benzene ring, and these electrons are delocalized electron. These electrons are delocalized. Delocalized means they are not localized. Not localized means they are not stable, they are moving. If they are moving, we are calling delocalized, and if they are delocalized means they are moving. And as we know that these double bonds are due to pi electrons, so as these pi electrons are moving, the double bonds are again moving, and as the double bonds are moving, we can change the position of double bond, but we have to maintain the one condition that there should be an alternate double bond. So we can change the position of double bond because the electrons are revolving. Okay, so this is all about the structure of benzene. Next, heterocyclic compounds. So as far as the classification of heterocyclic compounds are concerned, first class is simple structure. Heterocyclic compound will be of simple structure, fused structure as well as breeze structure. Simple means which has a single ring. Like this is an example of pyridine, in which the single ring, simple means single ring structure with one heteroatom. Next we have an example 5-membered ring. This is the 6-membered ring. This was the 6-membered ring, this is the 5-membered ring, but though it is a single ring, we are calling this ring as heterocyclic ring as pyrrole. Next, wherever the 5-membered ring with 2 double bond and oxygen as a heteroatom, this is called as furan. Next example, we'll see the 5-membered ring with 2 double bond and sulfur as a heteroatom. So thiophene, it is the name of the ring, and all we can see that these are categorized into the simple structure heterocyclic compound. Simple, why simple structure? Because single ring structure. So normally single ring, simple structure. Next, fused ring, name itself indicating fused, so in which 2 or more rings are fused together. So you can see that benzene ring fused together with the pyridine ring, we are forming quinoline. Same, isoquinoline. Sorry. Next example we have indole, in which benzene fused with pyrrole. This is the pyrrole. The pyrrole 5-membered ring fused with benzene. Pyridine fused with benzene forming quinoline. Pyrrole fused with benzene forming indole. So fusion is there, means among again As far as these two ring is concerned, one is homocyclic ring. We know benzene is a homocyclic ring. Second one is a heterocyclic ring. In this again same, pyridine is a heterocyclic ring which has a heteroatom nitrogen, and the benzene is a homocyclic ring. It's a fusion of homo and heterocyclic ring. It's a fusion of homo and heterocyclic ring. But finally it become heterocyclic because now it taken as a single structure and fused heterocyclic. Next, bridge, you can see that in which two rings are bridged by nitrogen. So in this way, so these are the this is the classification of heterocyclic compound. Next part we'll see in detail. Thank you.